So let's have an overview on different powers that we have in sinusoidal steady state analysis. So you should definitely remember this right triangle, that one side of that is P, the average power, and the unit for that is one side of that is Q, which is reactive power, and the unit for that is bar. And then the other side is the magnitude of S. S is a complex power. It's a vector, S, but here I'm talking about its magnitude, its length, that's it. And then this angle is theta V minus theta. So this angle is theta V minus theta. So this is a very useful, basically, triangle to remember. And this is the right angle, it's 90 degrees here. And the reason is that we can definitely know the relation between different powers. For example, if you look at the P is basically magnitude of S times the cosine of theta V minus theta. Okay, or similarly, Q is magnitude of S sine of theta V minus theta. Or you can also say, for example, S, the complex, the vector, the phasor S is P plus JQ. Basically, if you look at this as a P as a one side and that side, if you look at S as a vector, P S equal to P plus JQ. And also another notation for S, so S, as I mentioned, it's P plus JQ. Also, in terms of, this is a Cartesian, and in terms of a polar, you can say magnitude of S times C, the angle. If you look at this angle, is theta V minus. So the phase of S is basically theta V minus theta. Yeah. And also, it's very helpful to remember that this magnitude of S is, this is easy to remember. Remember power back in chapter 30, P equal to VI. So now the same thing we can say about the magnitude of S is V. However, here you have to use RMS times I RMS. Magnitude of V in RMS and magnitude of I in RMS. Okay, so this is the same if we say, for example, if you had V max and I max, then you need to have like half. Okay, but if you had RMS, it's just V times I. And again, remember, these are like the magnitudes, because in general, V could be a vector, again, a phasor. Let's say V, even the RMS is a vector, and I is also another vector, IRMS. But here we look at the magnitude. Magnitude of S equal to magnitude of VRMS times magnitude of IRMS. Okay. Okay, so these formulas are very, very helpful. Now, let's say an element in a circuit is given. You have an element Z, a load element Z. And let's say somebody gives its voltage. For example, I know a V in terms of, let's say, VRMS, the magnitude, and its surface. theta V. So let's say this is given. And some other like information about either P, Q, or power factor. By the way, this cosine theta V minus theta I is also called the power factor, as you know. This is called the power factor. So let's say some information in this triangle, let's say given, and we would like to find the I. Find I, let's say again Rx. What's I? Which this includes basically finding the magnitude of the current in terms of RMS and the phase of the current, which is theta I. Okay, so this is what we need to find out, given some information that's given. Now I can give you some scenarios, for example. So this part is given, again, this part is given. And let's say I have V, again, I have V RMS and the theta V. And also, let's say I am also given the P in terms of watt. And I'm also given power factor, which is cosine of theta V minus theta I. And whenever they give you power factor, they have to also mention if it is leading or lagging. Okay. So if it is leading or lagging. Okay, because basically we can have two scenarios. In the leading scenario, so that by the definition, they say it's leading if I is ahead of V, and it's lagging if I is not. Okay. So therefore, to know basically the relation between theta V and theta I, we also need to know which one is leading or lagging. Okay, and it's usually given to us. Okay. So let's say therefore this information is given. So from power factor, so these are given. These are given. And let's say I want to find the current. So from power factor, I have the cosine. I can take the cosine inverse. And then I can find basically theta V minus theta I based on leading or lagging. And also I have theta V here. So because I have theta V, from this I can find theta I. Again, just be careful about the leading or lagging part to see which one is I more than, or the theta I more than theta V, or theta I less than theta V. Just be careful about that. But anyway, just put this information together. So you find the phase of the current, but still you need to know the magnitude of the current. So P is also given. So in this case, I can use this formula that P is equal to magnitude of V RMS, magnitude of I RMS, times the cosine of theta V minus theta I, which is again power factor. So this was given, P was given, the voltage also was given. As you can see, we can get the IRMS from here. Okay, so we can get this one from here. So you have the now magnitude of the current and phase of the current. Therefore, I would be the magnitude, and then the phase of the time, the amp, and if this is the RMS, say RMS of the given. Okay. So therefore, maybe it would be good to add here also that in this formula, that this magnitude of S, as I mentioned here, is V magnitude of V times magnitude of I. So therefore, we can also here add that here P is equal to magnitude of V RMS magnitude of I RMS times the cosine of theta V minus theta. The same with V RMS I RMS times sine. Okay. So again, from the power factor that somebody gives you, let's given the problem. you can find the basically theta v or theta I, whichever is not given. You can find the phase. And from information of, let's say, P or Q, you can find the magnitude, okay? So this was one scenario. Another scenario we can think of is, let's say, instead of P, if Q is given. Let me add to this. Okay. Now, let's say, again, the same situation. You have a load. The voltage is given in terms of magnitude and phase, and you want to find the current. But now assume now this time Q and power factor. Okay. So again, from the power factor, you get the angle. So you get cosine. So this is basically cosine of theta v minus theta I is given. So you take a cosine inverse to get theta v minus theta I. Again, here, be careful about leading or lagging. You have theta v, so you can find out theta I. So you find the phase of the current. And from the Q, again, we use this formula that V RMS magnitude, I RMS. Now here we have the sign of theta v minus theta I, but that's okay because I already have the theta v minus theta I. I already have theta v minus theta I put here. Again, be careful about the which one is leading, which one is lagging. It's I ahead or V ahead, because that makes a difference in here in this formula, if it becomes positive or negative. Okay, so just be careful about that. But then Q is given, let's say magnitude of V is given, and you calculate that, and then you can find this easily, right? You can get this. Now, similarly, let's say if somebody gives you S. Okay, so if somebody gives you S and power factor, you can think of that too, right? If that's the case, so let's say magnitude of S and power factor. Again, from power factor, you get the angle, theta v minus theta I, and from that you get theta I. And then from S, is just V RMS times I RMS. If S is given, let's say this is also given, you can easily get this one. So you can, again, in this triangle, you can think of different combinations. Some of them might be given, and you can find the other one. So for example, in the first case, P was given with the power factor, which somehow gives me information about theta v minus theta I. And based on that, you can find everything else. Or the second scenario was when Q was given and the power factor again. Yeah, you can find the other ones. So, or S is given and the power factor is given. So make sure you just practice on these calculations. And let's say then after we find the current, somebody says, okay, now what is the S? What is the complex power? Right, this can be also a scenario. So let's say V was given as the magnitude and the phase, and then you also calculated I as the magnitude and phase. Now, if you want to find S, what is S? What is the complex power? So for this one, there are different ways. For example, you can go with the V times V RMS times I RMS conjugate. This is one way of doing that, or because you already have the magnitude, then also you can say, okay, I have the magnitude V RMS, I have the I RMS, and then the angle is basically theta v minus theta, right? They're the same. Am I correct? Let's conjugate. So let me check on that. Yeah. Yeah, exactly. The negative is coming from the conjugate. That's my theta V minus theta. Right. So either way, again, now given these two, you can either say the whole phasor of VRMS, this is times I conjugate, or I would say also like you have just the magnitude. Just multiply the V and I, the magnitudes, and then the phase is theta V minus theta. Yeah. So that's finding the S. And you can also think of more scenarios, right? So you have the voltage, the whole voltage as a phasor. We also calculated the I as a phasor. And let's say, what is the value of Z? Z is the phasor of V divided by phasor. Yeah. We do this. And then this Z, it is impedance, right? In general, it could be a complex number. Right? So it will have some real part. And then it might have also some imaginary part. Now remember in the class I told you, if X is positive, it's gonna be an inductor. So if X happens to be positive, it's like, remember J omega L, it's gonna be similar to J omega L, right? So it's gonna be inductor. Now if X happens to be negative, it reminds us of, because it's going to be minus J, so it reminds us of minus J over omega C, and that's going to be capacity. And R is also, the real part is always the resistor, right? Oops. Oh.